They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth. The Post's claim that the telescope captured the object changing its trajectory.
The light of a visitor from beyond our solar system has finally been captured in its truest form by the James Webb Space Telescope. For the first time ever, astronomers now have a direct, detailed image of 3I/Atlas, an interstellar object that streaked through our skies and sparked both awe and mystery. Unlike the grainy or incomplete glimpses gathered before, this image is not an artist's rendering, not a composite stitched together through layers of guesswork, but a direct, real view. Webb's unmatched sensitivity and precision have brought clarity to a phenomenon that until now had been blurred in speculation. To see this object as it actually is represents a profound moment in the ongoing exploration of our place in the cosmos. Before we start, smash the like and subscribe buttons for more updates. When 3I/Atlas was first detected, it was cataloged as the third known interstellar object after Oumuamua and Borisov, immediately raising questions about its composition, trajectory, and origins. But no telescope had the raw power to pierce its veil of distance and faintness, to bring forth a clear vision of its form. Webb's near-infrared camera, designed for the faintest whispers of light, succeeded where others failed. The telescope did more than detect it, it revealed it. What lay in its data was not merely an object moving silently through the void, but a frozen traveler bearing the unmistakable signature of material forged around a different star. That moment, when astronomers saw the sharp detail, was the moment humanity crossed another invisible threshold in cosmic awareness. The first thing that strikes the eye in Webb's image is the brightness, far more concentrated than anticipated. Instead of a faint, streaking smudge, the telescope unveiled a compact body with a halo-like glow trailing faint gases. The shape is neither perfectly spherical nor dramatically elongated, but subtly irregular, suggesting that 3I/Atlas endured violent forces in its past. It carries scars, fractures, and surface features that testify to collisions or tidal stress near its home system. Unlike a comet native to our solar system, its surface composition does not perfectly match any familiar profile. This fact alone underscores its alien identity, not merely in the sense of distance, but in the very chemistry of its makeup. The implications are staggering. For centuries, humankind has gazed outward and theorized about the materials that make up other planetary systems. With meteorites, we have held pieces of our own solar system in our hands. With distant stars, we have inferred the presence of worlds through dim light curves. But with Webb's image of 3I/Atlas, we now possess a direct snapshot of matter that formed around another sun. It is as if a message in a bottle drifted across an ocean, landing at our feet, and instead of peering from afar, we finally picked it up and opened it. The clarity of the Webb image allows scientists to measure reflectivity, assess surface grain, and even parse out traces of ices or minerals that hint at the environment where this body once dwelled. Seeing 3I/Atlas in this way also sharpens the discussion of interstellar dynamics. Its path through the galaxy was not casual but accelerated, carrying the record of gravitational slingshots from massive stars, or even encounters with unseen exoplanets. Every detail captured in the Webb image, every ridge, every shimmer of gas, encodes information about its history. It is as though the telescope has frozen time, allowing us to read a biography written in stone and ice. And unlike other telescopes, Webb operates across wavelengths invisible to the human eye, revealing spectral signatures that might otherwise remain hidden. What it records could reveal the abundance of carbon-bearing molecules, water ice, or exotic compounds that Earth has never known. The significance extends beyond academic study. When astronomers present an image like this, they are not only enriching scientific journals but also reshaping the public imagination. Webb's portrait of 3I/Atlas will circulate across screens and publications, becoming an emblem of humanity's curiosity and technological prowess. The power to capture such an image did not come easily. It required decades of effort, billions in funding, and the perseverance of countless engineers. But the result justifies the endeavor. A true image of an interstellar traveler does more than confirm a theory. It validates the human capacity to reach beyond immediate horizons. The very scale of what Webb achieved should not be underestimated. 3I/Atlas was moving fast, its brightness fading, and its trajectory taking it farther from the sun each day. By the time Webb locked onto it, the window of opportunity was narrowing. That the telescope succeeded in resolving it in detail is testimony to both planning and sheer capability. It demonstrates how space observatories are not just passive listeners to the universe, but active participants in its unfolding story. With each target Webb selects, it writes another line in the chronicle of cosmic discovery. And with 3I/Atlas, it has written one of the most extraordinary yet. What is especially moving about this moment is the way it unites questions of origin. Every rock and ice particle in our solar system tells a story about this star, our sun. But 3I/Atlas whispers of a star we may never see directly, one whose planets may have formed, evolved, and perhaps even harbored the seeds of life. To look at Webb's image is to gaze at the physical evidence of another system's existence. It is to be reminded that the Milky Way is not a backdrop but a community of stars, each with its own potential for wonder. In this sense, Webb's capture of 3I/Atlas expands the notion of home. Our solar system is no longer the only source of celestial artifacts in our possession. The image also enhances the dialogue about interstellar visitors as a class of objects. With just two previously identified examples, scientists had little basis for comparison. Oumuamua's odd acceleration sparked debates, while Borisov's comet-like tail suggested familiar processes. Now, with 3I/Atlas clearly imaged, we can refine our categories. Its structure may bridge the gap between expectations, not as elongated as Oumuamua, not as cometary as Borisov, but something distinct, perhaps representative of a broader population yet unseen. Webb's precision brings nuance to what might otherwise remain guesswork. It confirms that interstellar objects can differ dramatically from solar-borne comets and asteroids, offering a diversity shaped by foreign suns. Each pixel of Webb's observation contributes to models of planetary formation. If 3I/Atlas holds compounds uncommon in our system, it suggests that other protoplanetary disks follow different recipes. Such diversity implies that the galaxy is more varied than once thought, each star a chef in a vast cosmic kitchen, mixing elements and baking worlds according to unique conditions. The real image allows scientists to test these theories directly rather than extrapolating from distant starlight. That is the true breakthrough, not speculation, but observation. For the first time, we are not imagining what an interstellar object looks like. We are seeing it. This revelation also deepens the philosophical impact. In contemplating alien worlds, we often rely on the abstract: equations, probabilities, analogies. Webb's image of 3I/Atlas transforms that abstraction into presence. It is there, undeniably real, not an idea but a thing. That physicality changes how we think about the galaxy. The distance between us and the stars feels less like an impassable void and more like a highway upon which travelers occasionally arrive. And if travelers can arrive, then perhaps they can depart as well, carrying with them traces of our world into theirs. The cycle of exchange is no longer theoretical. It is embodied in the frozen contours of 3I/Atlas, now etched into Webb's detectors. The achievement also reinforces the role of the James Webb Space Telescope as the torchbearer of astronomy in the 21st century. Its mirrors were designed for faint galaxies and ancient starlight, but here it has captured a relatively small, fleeting visitor. That flexibility is profound. It shows that the telescope is not only a window into the deep past of the universe, but also a responsive tool for the dynamic present. The cosmos is not static, and neither is Webb. Its ability to turn from the edge of time to the edge of our solar system and back again defines it as one of the most versatile instruments humanity has ever built. The unveiling of 3I/Atlas through Webb's eye also reignites wonder. Wonder is not a trivial byproduct of science. It is its lifeblood. To look upon an image of a foreign object is to feel the same pull that drove ancient navigators across oceans and philosophers to chart the heavens. The photograph is not merely data. It is a testament to yearning, to the impulse to see and to know. Every person who lays eyes on Webb's capture of 3I/Atlas participates in that yearning. Whether they are a scientist dissecting spectra or a child gazing at the stars for the first time, this event will be remembered as a turning point in the way interstellar objects are studied. For the first time, we can say not only that such travelers exist, but also what they look like. Webb's image provides a benchmark, a standard by which future observations will be measured. It ensures that when the next interstellar visitor appears, and it surely will, we will know how to prepare, what to look for, and what to expect. It lays the foundation for a new branch of astronomy, one concerned not only with distant exoplanets or ancient galaxies, but with the migrants that pass between stars. There's also the subtle thrill of proximity. While galaxies are billions of light years away, 3I/Atlas came close enough to be imaged in detail. Its very passage through our skies is a reminder that interstellar space is not empty but alive with motion. Objects wander, collide, and disperse, carrying with them stories of creation and destruction. To witness one up close is to brush against the dynamic fabric of the galaxy itself. Webb's image is the proof. We are not isolated, nor are we static. We are part of a vast circulation of matter, and every so often the universe delivers evidence directly into our neighborhood. For all these reasons, Webb's image of 3I/Atlas will resonate for years to come. It is more than a scientific achievement, it is a cultural milestone. It will inspire new questions, new missions, and new ways of seeing ourselves. It redefines what it means to explore, shifting the boundary of the known outward by one more step. In the silent glow of that captured light, there is a message not only from another star, but from our own species. That we are capable of reaching beyond imagination and into reality, of turning the unseen into the seen, the unknown into the known. The moment Webb's detectors fixed on 3I/Atlas and produced a true image, a new chapter in astronomical storytelling opened. What had been only speculation, sketches, and models became tangible. Yet the event is not only about a picture, but about the cascade of insights and ideas that flow from it. With each pixel recorded, astronomers gained a reference point for testing theories about interstellar origins, stellar neighborhoods, and even the future of cosmic migration. One of the immediate fascinations with 3I/Atlas is the way it embodies the journey of matter across unimaginable distances. Unlike a comet that has circled the sun for millennia, this object originated elsewhere, perhaps ejected from its birthplace by the gravitational violence of giant planets or passing stars. The fact that it now drifts through our solar system is evidence of the galaxy's constant churning. Webb's image is not just a portrait of a frozen traveler. It is a record of galactic dynamics at work. Each ridge and fracture on its surface whispers of a collision, a tug, or a distant resonance that altered its path, ultimately bringing it into our line of sight. The telescope's infrared sensitivity revealed not only the object's outline, but also the delicate shroud of materials surrounding it. The faint gases, almost invisible to ground-based observatories, glow under Webb's instruments. This glow suggests sublimation of ices, perhaps unfamiliar mixtures that differ from typical solar system comets. Such chemistry hints at the unique conditions of 3I/Atlas's stellar nursery. If the ratio of carbon compounds to silicates is unusual, if the structure of its ices holds exotic isotopes, then we hold in our grasp proof that planetary systems grow up differently under other stars. Webb's image is not just a photograph, but a laboratory sample preserved in light. What elevates this observation into something epical is how it reframes the notion of cosmic isolation. For generations, humanity has debated the existence of other worlds and their capacity to sustain life. Exoplanet discoveries confirmed that planets are common, but those worlds remain too distant to touch or see directly in detail. 3I/Atlas represents something different, an emissary from those very environments, crossing the void to deliver itself into our reach. Webb's image is the ultimate validation of that reality. We no longer need to imagine whether alien systems produce comets or asteroids. The answer is imprinted in this object's form. The very act of imaging such a target is also a lesson in the refinement of astronomy as a discipline. The difficulty of tracking a faint, fast-moving body cannot be overstated. Webb orbits the Sun at Lagrange Point 2, far from Earth's atmosphere, with instruments designed primarily for deep, steady observations. To redirect it toward a transient, fading interstellar body required coordination, precision, and technical daring. The success of that endeavor demonstrates that humanity can flexibly respond to fleeting cosmic opportunities. Every interstellar visitor has a narrow window of visibility. and Webb has now proven it can seize such moments. That flexibility sets the stage for future observations, ensuring that the next time an interstellar object passes by, we will not only watch but dissect its every detail. From the scientific perspective, Webb's capture of 3I/Atlas serves as the anchor point for new models of interstellar material. By comparing its brightness across wavelengths, astronomers can infer particle sizes on its surface, the composition of its dust, and the presence of volatile ices. When combined with spectroscopy, these measurements unlock chemical recipes. Each line in the spectrum tells a story about bonds forged in an alien nebula, about processes of cooling, accretion, and heating. Already, preliminary analysis of Webb's data is likely revealing unexpected ratios, perhaps higher levels of organics or different balances of carbon monoxide and water. The implications ripple outward. If other systems produce such compounds readily, then the ingredients for biology may be widespread. Culturally, Webb's portrait of 3I/Atlas electrifies imagination. Humanity has always sought symbols of connection beyond our immediate world. The moon once served as that unreachable frontier, then Mars, then distant galaxies. But this image presents something unprecedented. Not a destination we dream of visiting, but a visitor that has come to us. Its journey across interstellar space is a mirror of our own aspirations. Just as spacecraft like Voyager and New Horizons leave our system carrying fragments of Earth, 3I/Atlas arrives carrying fragments of elsewhere. The symmetry is striking, and Webb's image crystallizes it. To the human eye, it is a reminder that exchange between stars is not fiction, but fact. The philosophical consequences deepen further. To gaze at the real image of 3I/Atlas is to acknowledge that the galaxy is porous. Systems are not closed, self-contained bubbles, but open arenas in which matter flows. This flow undermines the notion of isolation and replaces it with one of connectivity. Every time an object like 3I/Atlas enters our skies, it affirms that the universe is not static but communal. Webb's role in making that connectivity visible gives science a profoundly human dimension. It allows us to feel part of something larger, to sense that we are not mere spectators but participants in galactic exchange. One cannot ignore the historical weight of this milestone. Generations of astronomers relied on inference, using faint blurs on photographic plates or ground-based telescopes to estimate size and composition. The leap to Webb's crisp, multi-wavelength image is like moving from myth to map. The myths of interstellar wanderers, long passed down through culture and speculation, now meet the map of an actual image. It is a rare instance where technology fulfills ancient imagination, bridging what was once folklore into empirical reality. Future historians of science will mark this observation as the point when interstellar studies shifted from theory to direct evidence. The image of 3I/Atlas also energizes planetary defense discussions. While this particular visitor posed no threat, its trajectory reinforces the reality that the solar system is not isolated from galactic debris. Knowing what these objects look like in detail prepares us to recognize, track, and respond to future arrivals. Webb's ability to characterize their surfaces could one day inform decisions about whether such a body contains hazardous ices or unusual dynamical properties. In a sense, the telescope not only reveals beauty but also sharpens readiness. Beyond defense, there is the lure of exploration. Webb's image raises the tantalizing possibility of future missions designed to intercept interstellar visitors. If we can photograph 3I/Atlas in detail from afar, could we one day send a probe to meet such an object directly? The first step in such ambition is understanding what they look like, how they behave, and what they are made of. Webb has provided that first step. Each contour captured in its image becomes a navigational guide for mission planners dreaming of spacecraft that might rendezvous with such travelers in the decades to come. The event also reinforces the notion that astronomy thrives at the edge of the possible. Few would have predicted that a telescope designed to glimpse the first galaxies would one day capture an interstellar object passing through our solar system. This adaptability is itself inspiring. It shows that curiosity cannot be confined to narrow boxes, that instruments like minds must remain open to unexpected opportunities. Webb's image of 3I/Atlas is therefore a lesson in openness, scientific, cultural, and philosophical. For educators, the event becomes an invaluable tool. Students can look at the image and know they are not merely studying abstractions. They can see with their own eyes the reality of interstellar travelers. Teachers can use it to spark discussions about chemistry, physics, and cosmology, anchoring lessons in a real-world, breathtaking example. For the public, the image serves as a bridge between the technical world of observatories and the shared world of wonder. It transforms distant jargon into visible reality, allowing anyone to participate in the moment. Webb's capture of 3I/Atlas also carries aesthetic power. The universe often reveals itself in beauty, and this image is no exception. The glowing halo, the rugged form, the silent trail of gases, these details resonate not only scientifically, but artistically. Poets, painters, and storytellers will find in it new inspiration. Just as images of Earth from Apollo missions reshaped environmental consciousness, this portrait of a visitor from another star may reshape cosmic consciousness. Beauty, after all, is often the most direct path to understanding. The broader implication is that we now live in a time when the line between human imagination and scientific achievement grows thin. A century ago, the idea of seeing an interstellar traveler would have seemed impossible. Even a decade ago, it would have seemed unlikely. Yet Webb's image makes the impossible ordinary, embedding it into the record of human knowledge. This progress accelerates our expectations. If we can image 3I/Atlas, then what else can we do? What other impossibilities lie waiting just beyond the threshold? There is the sheer emotional resonance of the moment. When scientists released Webb's first deep field images, many spoke of the tears and awe they felt. The portrait of 3I/Atlas carries a similar emotional charge. It is not simply another scientific result, but a symbol of humanity's persistent longing to connect with the unknown. To know that we have looked upon the true face of an interstellar traveler is to feel part of a story that transcends lifetimes. It is to understand that our species, fragile and brief though it may be, has found a way to reach into the darkness and draw forth clarity. This clarity will echo into the future. Generations not yet born will look back at Webb's image of 3I/Atlas and see in it the seed of further exploration. Perhaps one day, spacecraft will harvest samples from such visitors, or astronomers will catalog hundreds of them. When that happens, they will trace the lineage of their science back to this moment, to the first time we truly saw, an interstellar body in detail. Webb has gifted us not only with a picture, but with a foundation. Upon it, entire futures of discovery will be built. When Webb's sensors revealed the intricate structure of 3I/Atlas, the result was not merely a single achievement, but the opening of a vast new frontier of inquiry. This observation challenges long-standing assumptions about what interstellar objects should look like, how they should behave, and what role they might play in the broader dynamics of the galaxy. The image is not a conclusion, but a catalyst for new questions that could drive research for decades. One of the most immediate consequences of this capture is its impact on the study of galactic migration patterns. Every star system functions like a cosmic workshop, producing countless asteroids, comets, and fragments. Many remain bound to their stars, but a significant number are ejected, cast adrift by gravitational encounters. Webb's image of 3I/Atlas provides hard evidence of this process. It shows that debris can survive the violent ejection, endure eons of interstellar travel, and still retain its physical structure well enough to be imaged in detail. This suggests that countless similar objects are moving unseen across the galaxy, each carrying with it a geological and chemical record of its home system. The discovery also offers an unprecedented chance to refine stellar population models. By comparing the material composition of 3I/Atlas with that of known solar system bodies, astronomers can test theories about how elements are distributed across the galaxy. If its mineralogy reveals uncommon isotopes or unusual concentrations of metals, it may point to star systems with different nucleosynthetic histories. That in turn could reveal how diverse the building blocks of planetary systems truly are. Until Webb produced this image, such comparisons were hypothetical. Now they are grounded in observed reality. The observation has further implications for exoplanetary science. For years, astronomers have studied exoplanets indirectly, inferring their atmospheres and surfaces from light curves and spectral data. But an interstellar object like 3I/Atlas serves as a tangible proxy for those distant planets. If the object formed in a protoplanetary disk, then its composition is a frozen snapshot of that environment. Webb's ability to capture the object allows researchers to test whether alien systems create the same kinds of ices, silicates, and organics as our own. It is, in essence, a way to study exoplanetary chemistry without leaving the solar system. The very process of imaging 3I/Atlas also showcases how far astronomical instrumentation has advanced. Capturing a rapidly moving faint object requires unprecedented coordination between tracking algorithms, scheduling, and data processing. It is a triumph of engineering as much as science. Every pixel in the final image is a victory over challenges of precision pointing, stability, and data clarity. Such achievements illustrate the extraordinary adaptability of Webb and open the door to future observations of even more elusive targets. Another significant implication lies in astrobiology. The question of whether life exists elsewhere often revolves around the availability of organic molecules. Webb's infrared capabilities make it uniquely suited to detect such molecules in faint interstellar bodies. If compounds like methane, formaldehyde, or more complex organics are identified in the data from 3I/Atlas, it would suggest that the seeds of life are not confined to a single system, but spread widely through galactic processes. The image, therefore, is not just a portrait of a rock and ice mixture. It could be a glimpse into the mechanisms by which life's precursors migrate between stars. The event also reinvigorates the philosophy of cosmic interconnectedness. For centuries, humanity's narrative of the universe has been one of separation. Stars are distant, planets unreachable, systems isolated. Yet Webb's image of 3I/Atlas is evidence of exchange. The cosmos is not a collection of sealed-off environments, but a network of systems sharing material across unimaginable distances. This transforms our understanding of the galaxy from a static backdrop into a dynamic, interwoven fabric. Each interstellar visitor is a thread linking us to distant stars, and Webb's image illuminates one of those threads with unprecedented clarity. From a cultural standpoint, the observation speaks to humanity's deep need to connect with the unknown. Just as ancient mariners were guided by the stars to new shores, modern civilization is guided by images like this to new conceptual territories. The emotional power of seeing an actual interstellar traveler, not as an abstraction but as a detailed entity, cannot be overstated. It invites every person, regardless of scientific training, to recognize that we live in a galaxy alive with motion and exchange. Webb's achievement bridges the divide between the esoteric world of astrophysics and the universal human experience of wonder. There is also an economic and technological dimension to consider. The success of Webb in imaging 3I/Atlas validates the investment in large-scale space infrastructure. It proves that these projects deliver results not only in their primary mission areas, but also in unexpected discoveries. This strengthens the case for future observatories designed to complement Webb, perhaps with instruments optimized for tracking interstellar bodies. The image of 3I/Atlas becomes both a scientific treasure and a political tool, demonstrating to policymakers and the public that the pursuit of knowledge yields profound returns. For future exploration, Webb's success establishes a foundation upon which more ambitious missions can be planned. If we can image such an object from afar, the next logical step is to intercept one. Agencies and research groups have already begun conceptualizing spacecraft that could rendezvous with interstellar visitors. Webb's detailed image of 3I/Atlas provides the reference material necessary to design such missions, understanding surface features, potential hazards, and the kinds of data that might be most valuable. In this way, the observation is not an endpoint, but a blueprint for interstellar exploration. The event also sparks renewed interest in the search for additional interstellar objects. Until recently, only 2 had been confirmed. The fact that Webb has successfully imaged a third suggests that these visitors may be more common than once thought. If so, the galaxy may be filled with countless silent travelers passing unnoticed through the dark. Webb's triumph provides the motivation to develop new survey techniques and detection systems, ensuring that future arrivals are identified earlier and studied more thoroughly. Each new discovery would add another layer of context to the understanding initiated by the image of 3I/Atlas. Perhaps most profoundly, Webb's observation alters the psychological relationship humanity has with the universe. Seeing a real image of an interstellar visitor reminds us that our solar system is not a solitary island, but part of a vast archipelago. It suggests that just as we look outward, the universe also reaches inward, delivering fragments of its distant stories to our doorstep. This reciprocity redefines exploration as a dialogue rather than a one-sided pursuit. 3I/Atlas spoke first by arriving. Webb answered by capturing its image. In the context of time, this moment is extraordinary. 3I/Atlas will eventually fade from view, slipping back into the void, but the image Webb produced will endure. Archived in data repositories, studied in classrooms, displayed in museums, it will outlast the object's brief passage through our skies, becoming a permanent addition to the tapestry of human knowledge. Generations will look back at it as the beginning of a new phase of astronomy, the phase in which humanity began to see, directly and clearly, the emissaries of other stars. This permanence also reshapes our narrative of the cosmos. For centuries, the stars were silent, distant lights. Now, with Webb's image of 3I/Atlas, we can say with confidence that those stars send us material fragments, tangible evidence of their worlds. The universe is no longer silent, it is communicative, sending messages across space in the form of objects like this. To capture such a message is to affirm our role as interpreters of cosmic dialogue. The capture of 3I/Atlas also serves as a reminder of the fragility of opportunity. Interstellar visitors pass quickly, often disappearing before instruments can lock onto them. That Webb succeeded highlights the importance of readiness, coordination, and foresight in astronomy. It is a call to maintain vigilance, to remain prepared for the unexpected. The universe does not wait for us, it moves at its own pace. Our ability to seize fleeting opportunities defines the boundaries of what we can know. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on the James Webb capturing 3I/Atlas for the first time? We want to hear from you. Thank you for watching, and see you next time.